Roger, once again, Mudfossil University, talking today about Trovants, okay, Trovants, all right. These are the growing stones that they find in Romania primarily. However, this guy sent me the ones from China and is asking me about it, and I comment, and this is Edvard Gerazi. He's one of the Mudfossil devotees, and I said, well, they rust. And they're tendon balls. So, and I'll show you in a second. And he said they're growing and they mature daily, and they die. They mature and they die. Well, let's go into it a little deeper. So I said, well, they're these tendon balls, and they have a rust characteristic like iron. And he took exceptions to that, and that's good. I like this when people question me, say, well, how can you say that? I look at it this way, I look at it that way. So what he says is he follows the research, and he understands that the giant balls are tendon balls, and he's okay with that. So let's go from there. He says, I understand that, but the stone balls in the video he attached are from China and Romania are growing like mushrooms. Have a look. She is offering more videos. This is... what's her name? Sylvie, I think. And she just doesn't buy into the mud fossils. They're still alive. I was just wondering whether she's got some other ideas here, and I've looked at her videos, and I like everything she does. It's just that she doesn't get the mud fossils, I don't think. She's invested in the fact that these are old megaliths, and now she's all of a sudden coming up with things that are growing out of the earth. Well, they were here, and they're just changing their chemical structure based on the chemistry that's in the area. Now, let's look at what she has to say. And I'm pretty sure this is Sylvie. Yeah, New Earth. All right. You see, these are attached. I know exactly what they are, but let's look at them. You see how they're split here and there?
Hello. Yesterday, I stumbled upon information about a very interesting site in China which provides further confirmation of the points I've been making in regards to the living stones, the rocks as growing organisms.
Okay. I don't want to go against her research or anything, but I mean, I've looked into all this. They're not growing. These were in here, and what is happening is the flesh that's surrounding them is eroding. This is mud fossil flesh. I'm just sorry, it is. Now, she's thinking they're growing out of the stone, and it's not. The stone is growing away from the rocks. And it's a very slow process in most cases. But these as everybody knows who's following my work, knows these are stone balls, and they're all over the earth. And she feels that they're growing based on, this is skin cells, and I'll show you, the skin tendon ball investments. And, they're all over. It's just the way it works. And I'll show my stuff about it again. And I don't mean to run anybody down, but you have to understand that at some point you have to look at this in a different way, and that's what I did. So let's take a look at what I have to show. And she's wonderful. She's got a lot of really good research, done a ton of work. So this is nothing against anybody whatsoever. Don't anybody take it like that. All right, let's just look at a couple of Trovants. And these are Trovants. Now, what does that mean? You see these layers, a layer, a layer, a layer. They are, I can't account for the process because I haven't done the chemistry on it, but I know the anatomical part, and I know really what this is. And you can see these little lichen spots, that they grow on where there was blood. They love blood. So they're growing all over these things like little spots. There's activity going on in this. Now, I don't think they're growing. They may be absorbing from the earth. They may be some kind of biological activity in there. I can't say for sure she's wrong. But I can tell you one thing, these started out as tendon balls, and that's where the straps held attachments. Now, let's look at a couple other shots. All right, there's a tendon cluster, and I'll show you why I can virtually prove what I'm saying. And these are in some form of a fleshy investment here that deteriorated and shrunk back down. It might even be a bone that it was attached to, but again, I haven't done the chemistry on these, but I do understand the process, understand the anatomy, understand the chemistry that I'm looking at by the transition metals, not necessarily. See, in other words, this is blood. That's blood. These different yellow things here, that is something leaching out of the ball, making it expand, I believe, and it may not be expanding, but it is some kind of chemical reaction to whatever is in the air or pollen or something that is unique to this particular area. And that's why I believe these Trovants grow. Now, whether it's absorbing something from the soils, which could be natron, or I have no idea what it could be. But if you did the tendon chemistry of some of them and the tendon chemistry of others, you could make some kind of conclusion. But I do believe it's all conditions that it preserved under. What was the local conditions where that thing petrified? Was it in a heavy, watery, muddy place where it got underneath the mud and it was very, very fine mud? Was it in a whole pile of fleshy stuff and it was one of the things on top of another thing? I mean, there's a million different ways it can happen. Was it in blood? Blood causes opals. I've shown this a million times. Blood, because it's the transition metals. It's all about how things bond. All right, and these are the different types of tendon balls. And they invest in different ways. There's ones that sink into bones, and there's other ones that strap across your stomach and your ligaments and into muscle versus bone and so forth. But they're tough, and they have a little tiny strap that comes down to every ball. And I can show you where there's a ton of little balls all in one place. They're all over your skin. They call them interstitium now, and they're everywhere. And I've found them in my mud fossils for years, and they come in extremely large sizes. All right, what you see in here, at one time, this was skin, and it covered a layer of skin over the top of this, a very thin film, which is really clay. And these balls were all stuck in that clay everywhere, and all spread out nice and evenly with all little straps running between. So you could stretch, it would come back. You stretch this way, it would come back. When that creature was alive, it died, and it became petrified, and the clay washed away. You can see clay all over here, the little dusty looking clay, and you see the balls everywhere. Those are interstitium balls. Those are tendon balls. They are tough as hell. That was some kind of I don't know what to say. It was something that was fleshy stuff surrounding here, and that all eroded away. But the tendon balls are so tough, that little stalk will hold that up virtually forever. They are just absolutely incredibly tough. And if you look careful at a lot of them, they all break. Well, they don't all break, but a lot of them fracture right in the middle, and they have they have the dark blood and the lighter blood going in there to service it. Where you see them around the world, you usually see like a little spot on them where the tab broke off, which is the strap, and there's an abrupt transition right here from the actual mineral ball to the flexible strap, which is not stretchy very much at all. And then there's another abrupt transition, and there is a couple of them as it goes along, and I don't think they even know how many abrupt transitions there is, because I found at least, I think, 4 or 5. Now this is absolutely incredible. This was sent to me by Scott Wiles. I think this is over in England somewhere. These are the flexible straps that go back. You see that little fiber stuff? That's the flexible strap that attaches to this tendon ball, which is embedded obviously in the mud. Now let's look at it. That's the tendon ball right here. All right, now then there's this abrupt transition that glues right to it. Remember in the other ball I showed you? And then it starts to change. So there's an abrupt transition here, another abrupt transition here. And that is the fibers. They're glued to that ball. And I mean, that glue is unbelievable. I would look to see what the chemistry is here between these things, because when they stick to those balls, man, they are stuck. And that is the stalks. This is the tendons. That's the tendon strap, and that's why it's so fibrous. I have one here. Here, hold on. I got it. All right, look. You see what you saw there? This is the same thing. You see this fibrous stuff right here? See, that's the same fiber stuff right there. Now that runs right over to this tendon wall, that round ball right there. That's the tendon wall. Now, this one here, whoops, I'm pointing my finger over here. The one there, what you're seeing is this strap coming up. And you see the fiber, well, you probably can't see it, but this is the part coming off the ball. This ball is eroded and broken off. That ball would have been normally a regular ball. That strap was going in. What we are seeing over here is that strap coming out right up through the top of, whoops, right up through the top of it. All right, and then coming over here and turning into this fibery stuff. All right, so that's the ball right there. There's that big round ball, which for them is in the mud. So we're right up here on that one. And that's the gluey stuff. I don't know, you can't see it here, but it's got the same stuff. It's the gluey stuff, the strap, and then it turns into fibers, which would have wrapped around here. This is a meteorite. You see this? This is a meteorite, and that was biological. I don't care what they say. That is a meteorite. That's how it's scalded like this, coming through the atmosphere. I'm sure it was at night when it wasn't bombarded with all the extra electrons. It scalded it and blew out the side, which is the red blood side, which is always the side that explodes, and the other side does not. It doesn't blow out. That's the black blood side. This was a fingertip. I'm almost certain, and that is one of the tendon balls that hold your tendons in so you can move your fingers around. And then there's another one over here and another one down here, and they come out, and that's how you can move your fingers around. This is the tip, which has the apical tuft embedded in there. This is the back. That would have been the red blood coming in. This is the black blood side right there. That's it right there. That's the vein. This one would have been here, the red one, but it explodes because that's a soft blood, and when it came through the atmosphere, that's the organic stuff that exploded. But I am going to guarantee you 100% there'll be DNA in here, and I'm not going to do it again because I've done 3 DNA tests on giants that are absolutely certain, and nobody will look at them. So if you want to know if this meteorite, which is a meteorite, if somebody can say that's not a meteorite, you tell me how it got scalded like that. Why is it exactly the way I would expect it to happen? That's a meteorite. So, case closed on that. All right, and that's a giant tendon ball, and those are the abrupt transitions. Abrupt, abrupt, abrupt. All right, I'm going to say, believe it or not, these were all those balls. They were all over this thing. These were the entrances to the straps, and they're all eroded away. This white stuff is kaolin clay. These are the investments, like I showed you over the top of the skin in the desert there, that has all the zillions and zillions of balls. Same thing. The straps have eroded. They're all over the place in here, and they're embedded in this white clay. And as that white clay erodes away, they will be exposed. The cords are they're the soft material. Well, they're softer than the balls. The balls are really tough. Now this is a different type of tendon. Like I said, some goes in bone, some goes in muscle. I mean, other tissues that are not bones, and they strap around your belly and all that stuff. And they have these flat tendon plates, and through them loop these straps. And these are, they call Chinese finger traps. You see the little things that go through there? That lets this thing pull back and forth against a muscle or a bone or whatever it's locked into. And that's the ball. And that's these balls you're seeing all over the world. And they come in clusters, as I showed you before. And as I say, there's bone attachments, there's muscles, and then there's ligaments. But they're all the same anchors. They use the same anchors. They're a little different. It's a little different chemistry, but they are the same anchors. And I have them here, and I know what these anchors, where they're attached, and I can see there's different chemistry in there. I've shown this, and there's missing a whole plethora of information in the medical realm by avoiding mud fossils. And I'm going to show you what a heart is made out of and what kind of tissue it would love to be associated to by color. All right, these are transition metals. You see all these different colors? Those colors are what transfer things through your body, and they attach to tissues, and they want to attach to tissues to bring and take away different products. So the tissue, that when it dies, it says, you know, I really like to be with this green guy, or I'd rather be with the pink guy, or this one here with the blue guy. So let's see what happens to a heart after it dies in blood, because that's what these are. They're dense in your blood. All right, this is a human heart, and they did some kind of surgery on here and made some kind of repair. Excuse me. Now, that's the plumbing, let's call it, the aorta, all of that business where tubes come in and go out for your heart and your lungs and the veins and the arteries. Now, these are ventricle walls and heartstrings, all this little gooey stuff in here is all biology of the heart. Now, you look at this, it's all brown. You say, yeah, it's all brown. Well, it's all the same tissue. Yeah, it's all the same tissue. It's all brown. No, it's not the same tissue. It's 100% different in every single area. Well, I'm going to show you why I can say that. And this is why I can say that. That's a heart too. It's an opal heart. Now, how did that happen, Roger? Well, opals are petrified heart. Well, not always a heart, but they're petrified organic items. Okay, clamshells, nautiluses, and all kinds of body parts. I mean, all kinds. I've seen them all. Now, how did that happen? There's a couple different processes, I think, that are at work. One of them, you have to have enough transition metals to come in and invade the tissues and link up with all of the different tissues that want to be linked up with the blue stuff and the green stuff and the red stuff and the pink stuff and the brown stuff, and all of the different stuff is different molecules. So how did it all change? How did this get all these blue stuff? The guy died at the same time. How would all that blue stuff get there? That wasn't blue in your body. That wasn't, the blood was red in your body, but this wasn't, all these different tissue, changes is from invasion of these molecules that make up these different tissues by these different transition metals. They come over and say, hey, I'd love to be with you guys. And say, well, we're still wet and gushy and we're looking to get stable. If you got some copper, you can come in. And if you don't have it, I really, you maybe come here and stay for a few minutes. But as soon as the copper guy comes, you're out. And that's what happens. And over the course of time, carboxylation, it's called, a carbon metal complexes move through all this, through aqueous solutions, and they end up becoming stable. Then eventually they dry. When they dry, they're opals. That's all it is. So, and all of these little tiny colors, you see that? Those are transition metals. Those are in your blood, and they are the product, the things that move products through your body. They bring stuff down, they take stuff away. They work by a tiny, 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 tiny pH change between your heart and lung area, and, because you blow out carbonic acids, which is a pH minus type of gas. And then way down in your toes and your extremities, you have just a little bit different chemistry, and it picks up molecules here, sends them off there, carbon dioxide, oxygen goes here and there, glucose, and all the different things you need to function and to keep all your body running correctly. That thing's not, if that was black, it's not going to work. It's not going to work. You have to have the right chemistry in your body. I keep saying this over and over. And we need a database that says, what are those molecules? What are those molecules in your blood? They don't know. They say, oh, you got this pink one and this green one. Or after that, we don't care. No, of course you care. All of these carry different things. You're not just two different chemistries in your body. You got thousands of different things going on. And you got little animals living in you that actually work for you, that need to be serviced and taken care of, and you got to feed them too. There's so much going on in people that they don't understand. But the database would tell everything is what is in your blood, every single thing that's in your blood, and what is the normal ranges. Right now they have no clue about trace elements, all kinds of things they don't know about. What is in your feces? They don't know about that. If there's no blood in there, they're happy. What is in your urine? There's a couple things, a little this, a little sodium, a little that. Yeah, you're doing all right. Well, there's more to it than that. And then when you put that in a database of this is what the guy's basic chemistry is, and now he's complaining about his hair, his toenails are falling out, he's going bald, and he says, are itching all the time. And, you put all that stuff in that guy's database. You don't have to have his name, nothing. You get 1,000 entries in there, and you're going to see this guy's got so much potassium, and that other guy's got no potassium. This guy's happy in his life. That guy wants to go commit suicide. It's going to be that's cut and dried after you get enough people in there. There's something going on in your chemistry that controls every single thing about you. And if you don't have it, you're not going to be healthy. You're going to be chronically ill. If your bacteria doesn't create enzymes, and enzymes don't harvest the metals that we're looking at here, to go out, and just like they do in the waste treatment plants, that you use these bacteria and the enzymes they create to go out and to work on products that are dangerous or hazardous. Well, they're coming to your body. They may not be dangerous or hazardous. You may need those, and you do need them. And these bacteria and enzymes have to work on, break them down into a small enough acceptable molecule that your body can work with. Otherwise, you can't work with 100-pound bricks. You need little tiny pieces to put together. And they come in your body, they're not ready to be worked with until your bacteria sends an enzyme package over there and says, all right, go ahead and chop this thing up with that enzyme. Simple as that. Go over there, beat it up until it's broken down into a small enough thing for the guy to work with. Because the guy screaming down there for the skin is saying that we don't have any of this sodium chloride, whatever it is. I'm just, there's all kinds of chemistry, but that has to be understood too. What is exactly in the top layer of your skin? What's in the next layer? What's in grip skin versus thin skin? All of these things are almost unknown areas. And you go in there, you say, well, my skin's bothering me. Well, what's in your skin? Well, I don't know. It looks like skin to me. Of course, it's red and raw, and you're scratching it all the time, but yeah, let's put a little of this on and see what happens. No. Let's take a sample and see if you have anything going on in there. You got any animals biting you? Who knows what's going on until you look at things. And then put it in a database. So anyway, I know I go after this every single time. I cannot help myself. Humanity is not being served by the medical industry right now. They're there to hand you pills, go home, see what happens. Castor oil can change your life. I'm telling you. It's changed a bunch of them. Jody's had said they told her there's nothing we can do for you. Take these prednisone pills, which will make your body not even care about being sick. That's what they do. We go home and that's it. And she said, no, I'm not going to do that. She put castor oil in her hands every night for a week or so, and they started to get better. And now they've been fine for it's been about 6 months now. And the only time she had any other issue with it was when she stopped doing it. She thought she was cured. And then the next day, after she put it on, within 24 hours, she was back to being 100% off of pains. And before that, she was sick and unhappy and in bed and crying and couldn't work and was looking at a miserable life. No, I don't know if it's going to change her life. I don't know if it's going to last forever. But it sure as hell looks like it's working to me. And she says it's working. She's thrilled. And her dog even was licking her paws all the time. Lick, 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 lick. She's giving her antibiotics and all kinds of things. I don't know what she's giving her, but she says these are very serious drugs. She did this to the dog. The dog's been okay. The hair grew back. I'm not kidding you. So there's more going on. I mean, now maybe people pay attention if it helps a dog. I don't know. I tell you, it's unbelievable.